Welcome to the very first episode of NASA Science Live. This is our chance to take you behind the scenes so that you can get to know your space agency. I'm your host, Sophia Roberts, and today we're going to talk about the moon. But before we get into that, here's some of NASA's most recent news. We were all broken heart emojied to say goodbye to the Opportunity rover. But this really was the little rover that could, because it lasted 15 years, despite the original mission proposing for it to last for 90 days. We lost contact after a planet-wide dust storm. But, you know, it's not all sad, because this really afforded us a whole new generation of Mars exploration. Hashtag thanks, Oppie. Well, when this mission ended, we were proud to announce the beginning of a new mission, and it's going to look at the origins of the universe. This is called SphereX, and it's a look at one of the biggest mysteries in science. Namely, why did the universe expand so rapidly, like under a nanosecond after the Big Bang? I know. Well, let's zip forward a few billion years, and NASA is expanding the way that we do science. Instead of designing and building and sending out lunar rovers, we are going to buy space on landers from commercial companies. This will hopefully fast-track some of our science, so much so that we may have new science on the moon in as early as the end of this year. So, speaking of the moon, let's talk about our cosmic next-door neighbor. It's been 50 years since we first went to the moon, and the moon remains one of humanity's greatest achievements. So today, we're going to talk about what it takes to go back. It also generated a lot of brand new questions. So, because as science always does, we need to go back to find out more. Over the course of our show today, we're going to talk about a few important things. Obviously, our Earth's moon, the lunar legacy, we're going to talk about lava tubes, some moon mysteries, and our Ask NASA portion. And this is the most important part because this is a chance for you to ask us questions and for our experts to answer them. So our new goal is to go back to the moon for long-term exploration. And this has a whole new host of challenges that did not exist 50 years ago. Why are we going back to the moon? Because it really is the key to both the history of our Earth, our solar system, deep space missions to Mars. But with all these new challenges, we have to understand its environment. Just to give you a frame of reference, the longest any Apollo astronaut was out there was just over 3 days. And to go back long term, we need to understand its environment. One huge and critical thing we have to think about is the radiation. Now here on Earth, we have the atmosphere, which is going to protect us. But out on the moon, anything we send out on the moon is going to be baldly exposed. So let's hear a little bit more about that.
To every astronaut or spacecraft, the sun is a damaging source of radiation. All objects traveling through space must contend with this hazard, including planets. Even the moon has the scars to prove it. New NASA research suggests that some of the coloration we see on the moon could actually be a form of sunburn.
The leading hypothesis is that the magnetic fields are blocking some portion of the solar wind from reaching the surface.
The solar wind is the sun's continuous outflow of particles and radiation that fills the inner solar system. Earth's magnetic field provides a strong global shield against it. However, the magnetic field on the moon is much weaker, and it forms only small, localized bubbles of protection. In these spots, the sun's particles can be reflected back into the solar wind or funneled to nearby regions. The shielded areas under the magnetic field form pale swirls. Those bordering parts become darker. The contrast is so prominent, we can actually see it from Earth.
The magnetic fields in some region are locally acting as this magnetic sunscreen. You know, sometimes you put on sunscreen and you miss like a tiny little bit, and then you have a really bright red spot on your skin where you missed it. That's in some ways the analogy of this sort of region of the moon that is extra exposed.
Unfortunately, the moon's patches of magnetic field are not robust enough to completely protect human explorers from the sun's radiation. But further study of lunar magnetic fields could lay the groundwork for future innovations.
Well, what if we got a strong enough magnetic field that perhaps we could produce artificially? That's a question that I think remains to be answered, but the crustal magnetic fields on the moon and lunar swirls kind of provide a hint in that direction that we might be able to learn something about.
So with us today, we have 3 experts that are going to give us a better idea of what it's really going to take to go back to the moon. We have Dana Hurley, who's a planetary scientist, Noah Petro, who is a project scientist with the Lunar Reconnaissance Orbiter, and we have Kelsey Young, a research space scientist. All right, Dana, since you're right here with me, I'm going to ask you the first question, which is, what really do we need to consider to have what they're calling sustainable presence on the moon? And really, what does that in lunar environment look like?
Okay, well, so a sustainable presence on the moon means that we have astronauts that are going to be there for a long period of time, or we have astronauts that are coming and going and being able to go out to do experiments across the surface and that sort of thing. So we need to protect them from that radiation that the sun is spitting out and that's coming through the solar system from the galaxy. And so one of the ways that you can do that is by building shelters for them. So if there is some eruption of particles from the sun that's sending out a burst of high energy particles, they can get out of the way. But yeah, so that's the big environment that we have to deal with for our astronauts.
And have I also heard something about there's a bit of water also on the moon?
Yeah, that's really enabling if we want to have a sustainable presence on the moon, is that there is water in these permanently shadowed regions near the lunar poles. And if we can use water that's already on the moon, then that means that we don't have to take it with us. And that's a big cost savings, and that will enable us to send more missions to the moon. If we don't have to take everything with us, we can use products that are right there.
And just really quickly, like, how much water are we talking about here? Is there a lot, or is it?
Well, so it's a lot for the moon, because about 10 years ago, we didn't think that there was any water on the moon. And just over the last 10 years, we've discovered that there is this water here. And we probably could fill up maybe 1,000th of Lake Erie if you put all the water that's distributed through all those permanently shadowed regions together. So there's some water.
All right, Noah, I want to lob this next question to you, because you've had the opportunity to study it a little closer than we are here on Earth, studying the Lunar Reconnaissance Orbiter. So what do we know right now about the lunar environment today, and then what are we looking at today? So what have we, I guess, learned over the course?
Yeah, I mean, we have the benefit with the moon of having had 50 years of understanding, starting with really even the precursor to Apollo, but specifically with Apollo, humans on the surface of the moon, the experiments that we left behind on the moon to understand what's happening there. Measuring the radiation environment that Dana talked about, measuring the solar wind that's coming and planting itself into the lunar surface, but also understanding the changes that are occurring on the moon, how many moonquakes are occurring, the dynamic environment at the moon. So for 50 years, we've had the Apollo data, but for the last 10 years, we've had data from the Lunar Reconnaissance Orbiter. And what that data is showing us is really how the moon is changing. We've been able to observe new impact craters that are forming just about every day. That's changing the surface gradually. We're able to detect new environments at the moon. Dana talked about the poles of the moon, and these are really unique environments, some of which receive no sunlight, coldest temperatures in the solar system measured in these permanently shadowed craters. And so the combined data of Apollo and LRO is telling us that there's these really unique environments at the moon, some of which may provide shelter for future astronauts. We're seeing lava tubes that may exist beneath the surface of the moon. And so we now have this really robust picture of the lunar environment, its dynamics, how it changes. And boy, do we have a lot of places we'd love to go. We've identified a huge suite of places on the surface that would compel us to explore further on the moon.
I mean, you've talked about these impact craters. Is that something that really is happening daily, monthly, yearly? Like, how exposed would things be to it?
Yeah, I mean, there's this constant bombardment of micrometeorites on the lunar surface. The moon's being sandblasted all the time. Apollo astronauts were on the moon, as you said before, for as short as a few days. If we want to be there longer, we need to know how the moon's changing and what threat that poses to future astronauts.
All right, so you're lucky to have something close to the moon, but we don't always have that opportunity to. So Kelsey, I know you study things about other planets here on Earth. Can you tell us a little bit more about how we do that?
Yeah, absolutely. So we've heard a lot about Apollo. The Apollo astronauts were able to collect an amazing suite of samples that we're using right now today to learn new things about the moon. A lot of the water discoveries that Dana mentioned were found actually from studying moon rocks that were collected 50 years ago. But technology's come a long way since Apollo. We've been developing handheld instruments that astronauts would be able to use in their gloved hand to understand the geochemistry and the mineralogy real time of rock samples on the moon. We're developing geophysical techniques that we need to understand now by going out and testing these things in terrestrial analog environments here on Earth to be able to understand how exactly astronauts in the future will be able to use these instruments. We also want to go out to terrestrial analog sites to study scientific processes. What processes here on Earth do we actually see forming on the lunar surface as well? And one of those things is, just as one example of many, is lava tubes. We see lava tubes here on Earth that are incredibly exciting. We also think we see evidence of them in the Lunar Reconnaissance Orbiter data of seeing these features on the lunar surface as well. It's really exciting.
Yeah. So this is our chance now to have you guys have your questions answered. So if you go to Twitter and use the hashtag AskNASA, or in the comments below, you can send your questions along. So far we have one from Mark, who asks, do we have good materials to block the solar radiation, or is it something that still needs to be developed?
Well, that's a great question, Mark. So actually, the soil that is on the surface of the moon is really good at blocking the sun's radiation. From the Apollo samples, we see pieces of the solar wind that get lodged into the smallest grains, and they're stuck just on the very, very surface. So you don't need a whole lot. So we can use that soil, to build walls or to, provide shelter.
Great. We have another question here from Facebook, and it is, if the moon has no atmosphere, how can there be water?
That's a very good question. And in fact, the moon does have a little bit of an atmosphere, but the atmosphere of the moon is so small that when the Apollo capsule landed and opened up the door and let out the air that was inside, it doubled the entire moon's atmosphere. So, but it's very interesting. The moon gets hit by comets, and those comets have water in them, and if that water lands where it's really cold, it actually freezes into ice, and can be stable. It's so cold that it won't evaporate in billions of years.
But we're not talking about flowing water, rivers, oceans. This is a single layer of water molecules, maybe chunks of ice beneath the surface. So when we talk about water, we're not talking about water that we see after a rainy day here in Washington, D.C., or, at beaches. We're talking about this very different environment. The driest desert on the Earth is far wetter than the moon. So
right.
Let's make sure we have a good picture of what's actually there.
I mean, how would we get that then? Like, how would you collect enough to do anything?
Well, that's a great question. I mean, so you have to heat it up, basically, because the water is stuck to the surfaces, and if it's warmed up enough, it will leave. And the reason why it sticks is because it doesn't quite get warm enough. So you can go through and you can gather up a lot of the soil that has the water stuck to the surface and then heat it up and collect it.
Yeah, and that's one of the ways we know that the moon is so different than the Earth is, you look at any moon rock. Even the wettest moon rocks we have such a small amount of water that for 40 years people thought there was no water on the moon. Well, it's just a small enough amount that we actually couldn't measure it properly until the instruments got advanced enough to be able to tell us that it's there.
Right.
All right, so Janice from Twitter is also asking, considering the future of lunar exploration, what do you think the current debate is about the past? Should the landing sites of the Apollo 11 be protected as a cultural heritage site?
Yeah, absolutely. I mean, these are some of the most important sites, both for our nation's history and for the history of humankind. So I would absolutely argue that these are incredibly important sites we need to preserve. We all are also still learning a lot of things about the rocks collected at these sites. So I think there's still a lot to be learned from these sites, but absolutely their preservation should definitely be on our minds.
Yeah. I also think that it'd be valuable to go back to maybe one of the landing sites to see how the material that was left behind has changed. There we have equipment that's been on the surface for 50 years. How has it been worn by being exposed to that radiation environment, by micrometeorite bombardment? So there's a science question to be asked at one of the 6 Apollo sites as well. But maybe we keep Apollo 11 and 17, keep those pristine.
Yeah. And absolutely, by studying that too, I think you can learn a lot about a sustainable presence on the lunar surface when you understand how the environment is reacting with the technology that you bring to the lunar surface.
Yeah.
All right, we have one more question that we can ask for this segment, which is from Peggy on Twitter. What would be the most important tool that we could use on the moon to tell us about its inhabitability?
Well, I think measuring the radiation environment on the surface.
That's right. Yeah, that would definitely be helpful. And also to quantify what resources are there that we don't have to take with us. So finding out where that water is. So being able to understand whether that water is only in the polar regions, how much of it is at lower latitudes.
All right, thank you all for your questions. We are going to be answering more questions later on in the segment, but we really need to talk about these lava tubes that Kelsey had mentioned earlier today because that is so exciting. So let's take a look about what those are all about.
The moon originally was a big ball of magma. Through time, as the crust formed on the surface, the magma on the interior also slowly leaked to the surface. A lava tube is essentially a cave, an enclosed tunnel through which lava flowed, and if it was able to drain out, you now have this open cave through which you can conduct some interesting scientific experiments. Here on Earth, a research team studies lava tubes as a means for better understanding how we can explore and understand lava tubes on other planets and the moon. From some of our high-resolution images from the Lunar Reconnaissance Orbiter, we can actually see pits on the surface of the moon, and it looks like these could be the extensive lava tube networks. So they could be pathways that are tens to hundreds of meters long, they could be kilometers long. Understanding lava tubes, where and when they formed on the surface of the moon is just a really exciting scenario. These caverns have been protected from the space environment. So this really would be an ideal place to try and collect samples that tell us not only about the moon, but about the solar system in general and how it's evolved through time. Our next step's starting to plan robotic exploration of the moon again, and this might involve observations that would help confirm the presence of lava tubes or some of these subsurface void spaces. They may even be accessible by robots or, in the future, maybe even humans. To me, it just makes them a very interesting and exciting aspect to studying the surface of the moon.
Oh, that is so cool. I mean, there's really just a whole new world underneath the surface of the moon that we just still really need to explore. So, Kelsey, I know you know all about this, and that was just a taste of these things. So can you tell us more about these exciting lava tubes, and what else do we need to know that's out there on the moon to explore?
Absolutely. So terrestrially, when we look at lava tubes here on Earth, they tell us a lot about how the lava flows that you find them in were in place. So it tells you something about the volcanic history of that terrain that you're working in. We think the same thing about lunar tubes. By exploring terrestrial tubes here on Earth, we're able to learn something about how the terrains where we see the lava pits and potentially lava tubes on the moon formed. So we go out to these lava tubes here on Earth. We use handheld portable instruments that astronauts can use when they're on the moon to traverse on top of the tubes to actually image what's underneath the surface without actually having to go anywhere near the pit itself. So by doing this fieldwork here on Earth with instruments above the ground, you're actually able to understand what's below and actually perhaps deduce the volcanic history of the lunar surface.
Really wonderful. Let's answer some more questions. All right, using Twitter, #AskNASA, or in the comments below. And if you're just tuning in, this is NASA Science Live. So Janice on Twitter, well, no, we already did this one. Krish, I'm sorry, on Twitter is asking, what bachelor qualifications are there required for an internship if you wanted to join NASA?
Yeah, I would definitely say that NASA takes all kinds. I think science, technology, engineering, math, I mean, those are certainly normal paths forward to get into NASA, but we're really interested in all backgrounds, art, business, communications, media. NASA really needs all types to make our mission happen, and I would really just say follow what you're passionate about, and that's the best way to get involved, in my opinion.
Yeah, I think NASA attracts people who are just interested in learning more, and like you said, whether it's the science engineer or humanities, you know, NASA has a history office. The people who are putting on this show here are all NASA employees, and so NASA has this rich family from diverse backgrounds that really kind of make NASA such a unique and special place to work. But we also get great people coming from outside of NASA who we get to work with as well.
Yeah, so I work at Johns Hopkins Applied Physics Lab, which is just up the street here in Maryland, and we have interns working there as well. And we have interns that have, you know, math and computers and science and engineering backgrounds, and we also have all sorts of other work that we do.
All right, let's get back to the science. Jeremy on Facebook is asking, would those tubes under the moon possibly contain oxygen?
On the moon, probably not, but they actually could contain usable resources. There's a tube that we work in out in California that has ice buried way deep below the surface in an otherwise very hot desert environment. So it's possible that tubes contain something that eventually down the line could be used as a resource once we figure out exactly what's down there.
All right, we have a class asking us, and it's an earth science literature class on Twitter asking, from a 6th grade class, which is great. If you could jump high enough on the moon, could you fly into space?
Well, it's not just about jumping high, but also fast. The moon's got weaker gravity. It's 1/6 the gravity here on Earth, and so we've all seen the videos of the Apollo astronauts leaping around. Well, I suppose if Jack Schmitt had had his Wheaties that morning and jumped really high, he could have gotten enough speed to get up to go, leave the surface of the moon. But I'm not sure even Jack with Wheaties would have been able to jump, 1.5 kilometers per second, 2.5 kilometers? 2.3 kilometers per second to actually leave the gravitational field of the moon. Just jumping far enough is pretty cool. It looks, it's kangaroo hopping around the moon seems like a pretty good way to spend an afternoon.
But when you all 6th graders grow up and if you can make it to the moons of Mars, you could hop off of those. But don't do that because you want to be able to get back down.
Yeah.
It'd be pretty awful just to be floating out there without any other help. All right, CJ on Twitter is asking, are there any new moon missions being planned or constructed anytime soon?
Well, you mentioned earlier today, we've got this commercial program that's coming up with launches perhaps as early as this year. And so there are going to be missions going to the moon very soon. Last week, SpaceX launched an Israeli mission to the lunar surface. And so I think we're at the precipice of this new generation, this new era of lunar exploration with frequent smaller missions that can bring scientific payloads to the surface. And we'll usher in this new era of asking these focused questions on the lunar surface. I mean, we all anticipate a time when there may be bigger missions, and NASA has a process for proposing to do that, so that's in the pipeline. I guess I'd just say stay tuned because it's going to get very busy at the moon. We hope to get some company joining LRO and Artemis at the moon very soon.
All right, we have time for one quick more question, and that's for Manish on Facebook. Is one of the uses of mining water on the moon to provide fuel to propel us to Mars? Oh.
That's a great question, and yes, that is something that we can do because even though the moon does have a gravity well, as we just discussed, it is less of a gravity well than the Earth's gravity well, so it's less expensive to launch propellant off of the moon than it is to launch it off of Earth. So if we want to send anything, robotic or human space missions to Mars, then we could use fuel that we get from the moon, that we make from water there.
All right, thank you for submitting your questions. I want to send you guys some of my other questions really quickly. So the one final big question really for each of you, because NASA is gearing up to send all these new things out to the moon. So what are each of you guys looking forward to researching out there? Like, what moon mysteries do you need to know?
I would love to send something to one of those magnetic field regions on the moon that was in the earlier segment and understand how well those block the solar wind and what happens when you're close by there, and you can look to see how that solar wind is interacting with the surface of the moon and if it's even making water.
For me, I think the moon has this great intersection of both planetary science, earth science, heliophysics. So what would interest me is going to a location on the moon and drilling. The deeper you go into the lunar surface, the busted up soil, you'd be able to go back in time. And so if you drill deep enough, you might expose a layer that was at the surface of the moon 4 billion years ago. And by measuring that, understanding that, we'd understand what was happening on the sun 4 billion years ago and understand how different that time was than it is today.
For me, I think going back a couple decades ago, we thought that the moon was a fairly, it had been dead for quite some time. There really hadn't been a lot going on, but we're finding more and more that it's a very dynamic and, relatively speaking, young planet. We see evidence of volcanism from only a couple decades of millions of years ago. We're seeing active micrometeorite impacts on the surface. So I think understanding the recent past of the lunar history, which is never something we thought about being able to do, is something I think is really important.
Excellent. All right, we actually have time for one other question, which is great because we talked a little bit about at one point our diverse backgrounds coming either through internships, and I'm wondering how you guys did make your way to NASA.
So I studied physics in college, and then I went to grad school and got a PhD in the field called space physics. That's understanding that space environment and the sun and that sort of stuff. And then I had an internship at NASA, or a postdoc at NASA. That started my career.
Yeah, for me, I had great teachers who pushed me, encouraged me. My father worked on Apollo, so I was always just interested in space. But I had high school teachers who said, geology is great. And so I became a passionate geologist, unraveling the history of the Earth. And then I had a college professor say, you know, you can do geology of planets. I thought, oh, that sounds pretty cool. I'll do that. And so I did a summer internship at the U.S. Geologic Survey in Flagstaff, Arizona, which is a beautiful place to be. And that opened my eyes to the world of planetary science and what this career means. And then just sort of on this path of going to grad school and eventually ending up here at Goddard. It's a great path, but all because of encouragement of both family and some amazing mentors.
Yeah, and for me, really quickly, similar story to Noah's actually. I found field geology in undergrad, so the ability to be able to go out in the field for work and solve puzzles, essentially is what we're doing, was just completely fascinating to me. So when I was looking for graduate schools, I thought to myself, you know, being able to do this on other planets, are you kidding me? This is a job. So I actually, same thing, I got my PhD funded in part through NASA, came here for a postdoc, and I'm still here years later, so never left.
In just like 5 words or less, if you could take one thing to the moon with you, what would you take? If you could go.
Oh gosh, I would take a camera and do selfies all over the place.
I'd take a rock hammer and get as many samples as I could to bring back and study here on Earth.
5 words or less, I guess. In situ analytical technology.
You have one more word left.
Exclamation.
Yeah.
Well, we have actually one last thing from Patrick on Twitter, who's asking, could we ever raise animals or grow food there on the moon?
Yeah, I think we'd have to do it in an enclosed environment, in a habitat. The space environment's not suitable for life, so anything exposed to the surface would not thrive. But if you had a large enough enclosed space, the lunar module on Apollo sustained 2 astronauts for multiple days. Make that bigger. Bring your dog, bring your cat. I don't know, you could have a little farm there, but you need the space to do it. And growing in there would be fun. There are experiments on the space station where they're trying to grow vegetables. I mean, the idea of sustainability. We can't bring all the food with us. We're going to have to grow some of it. Everybody remembers growing potatoes on Mars. I don't think we could use lunar soil to grow potatoes. I don't know if there's enough nutrients in it.
I don't think so.
But if you bring your own soil, bring your own fertilizer, make your own fertilizer, you might be able to do that in your habitat.
All right, wonderful. Well, thank you guys for participating with this, and I want to thank all of you for also participating and sending in your questions through the Ask NASA hashtag. We will also be able to answer more questions. Our scientists are going to stick around a little bit to do it via the internet. We chose to do this live, you guys, because we really want to fuel your curiosity, and we think that answering questions helps all of us understand the universe. So if you have more questions, keep sending them along. And to learn more, go to go.nasa.gov/NASA Science Live. Next time, we're going to talk about what it takes to go interstellar. So see you all next time.